Hello, I'm Erwin Cockett, the founder and CEO of CurveNote, and today I'm going to be talking to you about improving metadata and reproducibility during the research process. And I'm going to be talking about this in the context of the tools that we are building at CurveNote. And those are authoring tools for scientists and research teams that integrate directly with computational notebooks like Jupyter Notebooks to improve and accelerate scientific communication. And by accelerating science communication, I'm mostly focused on how we as scientists work and how we share that work. For example, in traditional publishing workflow, sharing happens months after the scientific work is actually completed. And this is traditionally a PDF behind a paywall. And this, of course, has changed massively over the last several years as we move towards open access workflow and sharing preprints much earlier than journal articles. And so that acceleration of sharing and communication is starting to move upwards towards the scientific process, and as we work with open preprints. And really, the trend and a lot of the topics at this conference are about how to formally share and cite and collaborate on more and more of the scientific work that's going on. So the problem design and study design, data collection, analysis and interpretation, and that's much of the work that was traditionally sort of behind the scenes of a traditional publication. And so, for example, data and sample and software citations, pre-registration of studies, micro-publications to share components of work, and new ways to share preprints in progress. So that communication is moving upwards in the scientific process. And there is, of course, also a lot of informal sharing in this space as well. And as we move upstream, that communication does become much more sort of informal, in quotes, with lab group seminars, blogs, and tutorials, Jupyter Notebooks or computational notebooks in general, software documentation, open educational resources. And this is an area that we've been working a lot on at CurveNote, is really how to bridge the gap between this informal communication as scientists are working on their work, on their science, and how to bridge that to more traditional scientific artifacts. And our focus is especially in the context of Jupyter Notebooks, which are used in data analysis and interpretation, and thinking through the balance between archiving, interactivity, and reproducibility. And what we've seen is that helping researchers bridge this gap not only saves them time, but can have a whole lot of other benefits around metadata collection and reproducibility. So today I'm going to give a bit of a few examples of some of the tactics that we've been taking at CurveNote to help improve this informal scientific communication as researchers are working, and including helping them sort of capture rich scholarly metadata, integrating their computation and communication tools, and maintaining that metadata when they actually share their work, and allowing them to share their work in new, open, interactive, and in-progress ways. And so I have a couple quick screenshots to show that of what we are doing at CurveNote to capture this metadata, as well as sort of the persistent IDs behind the scenes, like ORCIDs and DOIs and RIDs, and integrate computational workflows from Jupyter Notebooks, as well as how you share that work, so that we can improve reproducibility, as well as have the chance to share sort of more interactive data. And the goal of this is to make it easy enough so that you can share this throughout the research process without a huge amount of overhead. And so I'm going to show a couple screenshots of working in CurveNote. And so this is CurveNote. It's primarily a writing tool for scientific content with integrated references and citations, as well as collaboration through comments and version control. And here you can see sort of someone writing and creating some cross-references to figures and equations. And that information is stored as data so that it is accessible when you actually share your work. And in this case, sharing it as a website. And so this is more of a browsing experience in this sense, where folks can click on sort of a cross-reference to a figure and bring up that rich information, both about the figure and any other cross-references inside of it. And that sort of really improves the reading and browsing experience. And this also works with more traditional citations through DOIs. And so those are directly built into CurveNote, allowing you to search through your entire reference collection without using your mouse. You just type cite and start searching through your collection. And then we can add rich information like abstracts pulling from DOI services like Crossref or OpenAlex. And so that rich information is again shown and sort of incorporated from these scholarly sources like DOIs, ORCIDs, RORs, OpenAlex, RRIDs. And I know Anita will be talking much more, or has already talked about RRIDs for biological research. So I'll let her take that one. But I think the real piece that I think is beneficial is showing that immediate benefit to adding that rich scholarly metadata while you're actually writing. And this encourages authors to actually add that information as well as validate that it is correct by able to sort of click on it and quickly see. The other major piece that we're focused on is going through every piece of content in CurveNote and making sure it has a unique ID. And this opens up all sorts of workflows to be able to integrate outputs from Jupyter notebooks that can be interactive visualizations directly in an article. And because they have that unique ID, comments and versions can sort of be passed around wherever that output is embedded. And that really aids in the collaboration and iteration process. And we've architected CurveNote to separate the content as data from the presentation of that content. And this means you can very easily change a template when exporting to a specific journal, although when exporting that loses any sort of interactivity and a lot of the rich metadata. And so some of our authors are choosing to share their work as websites that require minimal setup to sort of self-publish that work. And these allow authors to share more intermediate work and sort of more of the behind the scenes information. And of course, because it's online and not in a PDF or a Word document, there are a lot more options to explore with embedding interactivity and data directly into the presentation of results. And so this is an example of running a Jupyter notebook and showing portions of the results in narrative content, which is, of course, very helpful for educational use cases and tutorials. And so these are a few of the strategies that we've been taking at CurveNote to improve scientific communication. By integrating metadata and persistent IDs while writing, we're focusing on the immediate as well as the lasting benefits of additional data, like those abstracts and the descriptions and tags that are coming from the community. And we're sort of pulling for that reproducibility in science by integrating computational workflows directly into how we're sharing work. And ideally, by making this easy, as easy as possible, we are improving the iterations and collaborations when sharing that scientific work. And so I'm really excited by how folks are using CurveNote today to share more of their science, share it sooner, and share it more openly. So thank you so much for listening to my presentation. And please do reach out. I would love to hear from you. All right, thanks so much. Bye-bye.